This course is a discussion about the real money expenditure for a Hadoop cluster. This is a conversation about IT labor dollars. When Hadoop operations has the ugly reputation that nothing can be done correctly, when every change results in follow-on incidences, when there is rework on top of rework, Hadoop operation is in chaos. But another way to look past the frustration of chaos is to account for the amount of money being wasted on inefficient use of IT labor. We have discussed releases and changes, which are operational practices to reduce the number of errors introduced into our cluster. Now, let us discuss what happens when errors are indeed introduced. Our goal as IT professionals is to identify errors quickly, put the right resources to resolve them in a timely manner, and, most importantly, prevent these errors from reoccurring. You will only be able to provide stability when you have mastered the management of events, incidents, and problems. And stability equates to the most efficient use of IT labor. Instead of spending hours fixing things, we can spend the time improving things. So, let us not make the same mistake again and again. An event is defined as any change of state in the cluster. We need to manage events, both good and bad. We recognize that we do not need to capture every event, just enough of them to develop trends and provide information for analysis. When we set up an event management system, we determine which events and at what frequency we want to collect them. Now, an important definition. A bad event is called an incident. We want to be alerted on incidences, but not necessarily on all incidences. So, let's set a threshold to define our alert levels. Typically, we set thresholds for warnings and a threshold for critical reaction. We then adjust our responses to the incidences by setting these two different threshold levels. By the way, we all well understand that events result in alerts, and these alerts can be published in a number of ways. We can have them pop up in a window, we can send emails, make phone calls, etc., etc., etc. We're all familiar with these operational best practices. The event manager will collect and store these event metrics. These metrics can then be displayed into charts, or perhaps more importantly, they can be measured against thresholds to determine if an alert must be raised. There are a number of event tools for monitoring our Hadoop cluster. Just a few of the many event management systems that you can choose from would include Umbari, BMC Patrol, CA Unicenter, Cloudera Manager, Gangula, and Nagios. Most likely, your event management system will be selected for you as a data center standard. However, they all tend to function the same, and they all collect the same type of metrics from our Hadoop cluster. In this course, we're going to take an in-depth look at the commonly used open-source solutions of Gangula and Nagios. Our goal is to not only demonstrate their installation and configuration, but we really want to demonstrate how to use these tools with our Hadoop cluster. Most of the web consoles used for monitoring have the following architecture. There will be a central event monitoring server, and then around that server you will have an activity monitor, a host monitor, an event monitor, a reports manager, and an alert publisher. Take a moment and have a good look at this architectural drawing. We will apply this architecture to our use of Gangula and Nagios, and again later to our deployment and use of Cloudera Manager.